So now coming to the construction of a DC machine. This is called the construction of a DC machine. Okay, I think so construction. So what are the major parts are there in a construction? What are the major parts are there in a construction? This part is called the yoke. Here is clearly mentioned what is the purpose of the yoke and what is the purpose of the pole. So this one is pole here, and this winding is called the field winding. When it is excited with DC, it will produce as a constant magnetic field like this. Let us say this is north pole, south pole, north pole and south pole. It is a 4-pole machine. 4-pole machine. And so this is called the commutator segments, right? Already we discussed, right? This is commutator segment X and commutator segment Y. The conductors are fixed to the commutator segment X and the conductors are fixed to the commutator segment Y. And similarly we are having a, so this part is called the, what is this part is called the commutators, and outer parts is called these brush 1, 2, 3, 4 brushes here we are having, and this is called the armature here, armature core. So we can call it as an armature core, and the armature core outer periphery is slotted. Now we will discuss one by one. So this is about the constructional details. If you cut the machine, the cross-sectional view of the DC machine is like this. What is the purpose of the yoke? Yoke acts as a protecting cover for entire machine. The first part, yoke acts as a protecting cover for entire machine, and also it will give the field, it will give the support to the field poles. So this is called the field pole here. This one is field pole, you can see, and this is also field pole, this is also field pole, this is also field pole, and this field pole will be bolted or fitted to the yoke. This fitted to the yoke. Okay, and yoke acts as a protecting cover for entire machine. So whatever the insulating material is there, that is protected from the dust and moisture like silicon oxide, and this poles, these field poles are made up of so cast steel or silicon steel, and this is made up of cast steel for large machines. Yoke is made up of cast steel for large machines, and the cast iron for small machines. This is very, very important. So in overall BW subject, you can remember the materials. So that materials are very, very important. And these field poles are made up of silicon steel or cast steel also. For larger machines, it is laminated. For smaller machines, the laminations are not required. And this part is called the armature. And what is this part is called the pole shoe here, pole shoe. Okay, so what is the purpose of pole shoe? And the pole shoe which will gives the support for the field winding. Pole core, this is, we can divide it into two parts. One is called the pole core and another one is pole shoe. Pole core is made up of silicon steel or cast steel, and we can wound the winding. See here, wound the winding on the pole core, and this part, these parts are called the pole shoes. These parts are called the pole shoes. So why the shape of the magnet is, like this? So if you go for see here, so if the pole core is like this, and if the poles are designed like this, what will happen? There is no mechanical support for the field winding. Even if current is flowing through the windings which is excited with the DC supply, what will happen? It will be vibrated, and the windings are coming out of the pole core. So that's why, in order to get the mechanical support, and you can shape the pole. Pole is like this. Why? Because it will not comes out of from this pole shoe. Okay, generally the pole shoe is laminated for the larger machines, not required for the smaller machines. Why? Means this pole shoe is excited with alternating voltage and alternating current. See why? Because the armature is rotating with the help of a prime mover. The EMF is induced here. This is an alternating. As we already discussed, the EMF which is induced in the armature conductors is alternating. Once it will be an alternating, what will happen? This pole shoe will be experienced with the alternating flux. An EMF is induced in a core also. That is called the pole shoe also. This pole shoe is laminated for larger machines, not required for smaller machines. Even though if it is excited with the DC, what is the frequency of the DC value? The frequency of the DC value is equal to 0. But pole shoe which is experienced with the armature conductors. What is meant by armature means, see, This part is called the armature core, and we can call it as a rotating part of a DC machine is also called as a rotor or also called as a armature. The armature core is made up of silicon steel. Okay, and this is another cross-sectional view. See here, this part is called the rotor here. What is part is called the rotor. So this part is called the rotor. Okay, and this is yoke, and this is bolted to our so panels ki manam fix chestam kada, on cement panels ki manam fix chestam this type of motors, and the brushes, lugs, field poles. Okay, field poles nichi. So once you can take the field pole like this, okay, so and you can wound the winding. This winding is called the field winding, so which is excited with DC supply. It acts as a north pole, and one more pole is also there. So if you go for the one more pole, this pole acts as a south pole here, and what will happen? So pole core, it accommodates the winding, pole core, it accommodates the field winding, and when it is excited with DC supply, it will produce a magnetic field like this. Magnetic flux lines are coming from north pole and reaches the south pole. And pole shoe, which gives the mechanical support for the field winding, pole shoe which gives the mechanical support for the field winding, and it is laminated for the larger machines. It is not laminated for the smaller machines. And what are the major parts are there? Yoke. First one is the yoke. Yoke acts as a protecting cover for entire machine. It gives the mechanical support for the AC. This one is called the field poles, and also it provides a low reluctance part for the magnetic flux lines. Okay, north pole ఇప్పుడు మీరు ఏం చేశారు, దీన్ని ఇట్లా వౌండ్ చేసాం. Yes or no? This part is called the yoke here. What is this part is called the yoke, and the flux is coming from north pole to south pole. If you take here, so the flux lines are going from north pole to south pole, and innerly it is moving from south pole to north pole. Yes or no? Where it will goes now? Where it will goes? Tell me where it will goes. And innerly it will goes like this. Okay, so this part is called the from south pole to north pole. Okay, and next one. So this is about the DC generator construction. You can know clearly this part is called the yoke, and here we are having a terminal box. In the terminal box we are having a terminals and field terminals, and also called as a armature. This part is called the armature. Clearly you can see this part is called the armature. Okay, the rotating part of a DC machine is called the armature. Armature, so where we have to place the armature core, and second one is called the armature windings. Armature windings. Okay, so this one is called the armature winding here. Armature winding, and this ఈ brownish gold color లో ఉంది చూసారా, ఇది commutator, ఇది వచ్చేసి బేరింగ్. ఓకే, ఈ షాఫ్ట్ ఇది కనబడుతుంది కదా, దిస్ ఈజ్ కాల్డ్ ది షాఫ్ట్. ఓకే, ఒక్కొక్క దానికి ఒక్కొక్క మెటీరియల్ ఉంటుంది. వీళ్ళు డిస్కస్ ఉన్నాం. ఆర్మేచర్ వైండింగ్ వచ్చేసి దేని మీద పెడతాం? ఆర్మేచర్ కోర్లో పెడతాం. ఆర్మేచర్ కోర్ ఏం చేస్తాం? స్లాట్స్ ప్రొవైడ్ చేస్తాం. స్లాట్స్ ప్రొవైడ్ చేసి ఆర్మేచర్ కోర్ని పెడతాం, విచ్ ఈజ్ ఏంటి డిస్ట్రిబ్యూటెడ్ వైండింగ్ వీఆర్ యూజింగ్ in a armature. And also armature core is made up of silicon steel. That is very, very important. Core is made up of silicon steel. Core is made up of silicon steel. And windings, anyway, you know that it is called the copper winding. Low resistance and same story, low I square R losses. Low I square R losses. Okay, and if a silicon steel, why we are using a silicon steel? In order to reduce the hysteresis loss, and it is laminations are provided. Either it is any machine, is laminations are provided in order to reduce the eddy current losses. Eddy current losses. And see here, poles and pole shoes. If you go for the poles and pole shoes here, and poles are joined to the yoke with the help of a bolts or welding. Okay, so we can have this type of pole, and the pole is fixed to the yoke. This part is called the yoke here now. This part is called the yoke, and the yoke is bolted or fitted to the yoke with the help of a bolts. And what is the purpose of the pole core? This part is called the pole core, to give the and to wound the winding, field winding. Okay, to wound the winding, and also field winding. So field winding is made up of copper only. Once it is excited with DC supply, it will produce a constant magnetic flux. And this is the most important part. This is called the armature core. Now you can see how the laminations are made here, how the laminations are made. and the laminations are provided in order to reduce the eddy current losses. Okay, this is called the in order to produce the eddy current losses. I think you may have a doubt in transformers also how the laminations are provided. So this all these types of laminations are combined or clubbed together to form this core is called the armature core, and also this holes are provided for the cooling purposes. And if cold air is inserted into the this holes, and it will be cooled down. Okay, and the laminations are provided. One thing you have to remember in overall BW subject, laminations are provided in order to reduce the eddy current losses. Okay, now you understood how the slots are there. So you can wound a bunch of the winding is like this, bunch of the winding is like this. So you can wound, you can place the windings so in a different manner. So the winding will be distributed, and this is called the shaft. You have to insert here a shaft is inserted. Shaft is inserted, and this is called the shaft key. Okay, shaft key. So first of all, yoke is made up of a cast iron, cast steel for large machines, cast iron for smaller machines, and next one is pole core and pole shoe. Pole core is made up of the cast steel or silicon steel, and the armature core is made up of silicon steel in order to reduce the stress losses. Armature core is laminated in order to decrease the eddy current losses. And next one. So armature core is the rotor of a DC machine. It is cylindrical in shape. See here, the shape of the armature also you may ask. And yoke shape వచ్చేసి ఏంటంటే hollow cylindrical shape. Yoke shape వచ్చేసి hollow cylindrical shape. Hollow cylindrical shape. Okay, and the armature is built up of thin laminated circular steel disc for reducing the eddy current losses. It may be provided with air ducts for the axial airflow for cooling purposes. Armature is key to the shaft. Okay, what are the points we discussed? The same points is there here, and this is about the armature and type of armature. What is called the commutator, and what is called the shaft. The shaft is made up of mild steel. The shaft is made up of mild steel. You have to remember the materials. The materials are very, very important. And so the slots are provided, right? These are called the slot wedges in a DC machine. This is also very, very important question. It is repeated in so many times. Slot wedges in a DC machine. In a DC machine, slot wedges in a DC machine are made up of fiber. Made up of fiber. Okay, so it is usually a former wound copper coil which rests in the armature slots. Yes, bunch of turns we are placing. Which type of slots are used in DC machines? Open type of slots are used. Open type of slots are used in DC machines. In an induction machines we are using which type of slots? In an induction machine, semi-closed type of slots are used. Why we prefer the open type of slots? If the open type of slots air gap is more, where the leakage flux is equal to mmf by reluctance. If air gap is more, reluctance is more, the leakage flux is reduced. If a leakage flux is reduced, then the inductance value is decreased. If the inductance value is decreased, and then we should convert the negative off cycle into positive off cycle. Yes or no? With the help of a commutator, we are converting the negative off cycle into positive off cycle here. So this is the shape of the waveform here. And now exactly at this point it will be equal to 0. But because of this inductor, what will happen? Inductor does not allow the sudden change of the current. Due to that, it will be somewhat delayed. So that is called the delayed commutation. Commutation is a process which will convert AC in the armature conductors to DC in the load circuit. So that's why if inductance value is decreases, then tau time constant is equal to L by R. If L value is decreases, time constant is decreases. This delayed commutation is decreases, and the commutation process will be improved. This is very, very important. We have to improve the commutation process by using which type of slots? Open type of slots. While we are using the open type of slots, what will happen? Leakage flux is equal to mmf by reluctance. The reluctance offered by the open type of slots is more, then the leakage flux is less. If the leakage flux is less, what is the relationship, sir? N into phi L is equal to L into I. Have you forgot this formula? Where L is equal to N into phi L by I. So what is meant by phi L? Phi L is called the leakage flux. Phi L is called the leakage flux. The flux which links either stator or rotor, but not both the windings, is called the leakage flux. So the leakage flux will be reduced here with the help of a open type of slots. Leakage flux is reduced. If this leakage flux is reduced, what happened? The inductance value is also reduces. If the inductance value is reduces, then the time constant is also reduces. If a time constant is reduces, what will happen? It will be properly exact time. It will be the exactly at 0 point it will be converted into, and the next negative of cycle is converted into positive of cycle. So it is not delayed by decreasing the inductance. That's why we can use the open type of slots in a DC machine. So the armature conductors are insulated from each other. Yes, conductors also. మీరు నార్మల్గా కాపర్ చూస్తే ఒక కలర్లో ఉంటుంది, కానీ వైండింగ్ కలర్ చూస్తే కొంచెం బ్రౌనిష్ కలర్ ఉంటుంది. ఎందుకు కొంచెం థిక్ కలర్లో ఉంటుంది అంటే ఈచ్ కండక్టర్ ఈజ్ insulated. Each conductor is insulated so to the armature core, and the armature can be wound for one of the winding two methods. One is called the lap winding and wave winding. So what is meant by lap winding? So what is meant by wave winding?